add a new 2020 Premier or Essential Data Center through the UI, we first must log into the OVH Cloud Manager portal. We then navigate to the hosted private cloud that we're going to be adding the new 2020 Premier or Essentials Data Center to. This hosted private cloud has two data centers associated with it already, a sandbox that we will not be using, and this source vDC that will act as the source of the migration. To add the new data center, we navigate to the hosted private cloud and then go to the Data Centers tab. We then choose Add a Data Center and choose Premier or Essentials. Click Confirm. Here we need to select Next. Accept the terms and conditions once read. Review the selection and click Migrate. Add a new 2020 Premier or Essentials Data Center through the API, we must first log into the OVH API portal at api.ovh.com. We then want to find the hosted private cloud that we want to add a new Premier or Essentials Data Center to. And we do so by running a get API call against /dedicated cloud. Here we can see the hosted private cloud that we want to add the new Premier or Essentials Data Center to. But first, we must check that this service is eligible to move to the range by running the compliance API call. Here we can see that it is indeed eligible for the Premier range. We then need to go to /order to find the service name with the private cloud management fee API call. We will use this service name then to get our plan code. The plan code should look something like PCC Management Fee Premier or PCC Management Fee Essentials. Here we can see that the plan code is PCC Management Fee Premier. So with the service name and the plan code, we can now verify the addition of the new Premier or Essentials Data Center to the hosted private cloud. With this API call, we get a provisional order for the addition of the Premier or Essentials Data Center. And now we can go to create the real order using the post API call. Once the new data center has been created, we can add new hosts to it by going to the OVH Cloud Management portal, selecting the new data center and the Host tab. Here we can click on the Order a Host button. Once this is loaded, we can choose the host type and the quantity of that host that we want to add to our new data center. Simply click Confirm Order and go through the remaining order and payment steps. To add new data stores, we navigate again to the new data center and this time choose Datastores. Here we can click on the Order a Data Store button. And again, once this is finished loading, we can choose the data store type and the quantity of that data store we want to add to the new data center. Again, click Confirm Order and go through the remaining order and payment steps. To facilitate the migration process, we will usually want to convert one or more data stores to global. Converting a data store to global means that this data store will be visible and usable by ESXi hosts in both the source and destination data center. In this video, we will be converting the new data store in the new data center to global. And to do this, we must use the OVH Cloud API. So we must first get our HPC with the /dedicated cloud API. Here we can see the HPC that we were looking at. And we can use this to get the data center ID using the data center API call. Here we see 3 data centers in this hosted private cloud, this being the newest one, and we can confirm that this is indeed the ID of the new data center. So we can use this ID to find the data store ID by using the filer API call. And with this data store ID, we will check if it is first eligible to be converted to global mode using the check global compatible API call. The call returns true, meaning we are good to convert this data store to global. So finally, we convert the data store to global using the convert to global API call. The new Premier or Essentials data center is now provisioned. However, we still cannot see it in the vSphere web client. This is because we have not added any permissions to the vSphere user to view and use this new data center. To add these permissions, we go to the OVH Cloud portal, select the hosted private cloud, and go to the Users tab. Here we can search for a user we will be logging in with, in this case, the migration user. And to add the correct rights, we will click on the 3 dots and choose See Change the Rights for each DC. Here we can add the appropriate rights for the new data center to this user. Note that this needs to be done for all users that will need access to the new data center. Also, if users will manage token validation, IPs, failover IPs, or NSX, you will need to select Edit and choose the appropriate permissions. In this example, we have Veeam activated on the source data center. So to ensure backup consistency during the migration, we will also need to activate Veeam on the new Premier or Essential data center. We do this by navigating to the new data center in the OVH Cloud portal and selecting the Backup tab. Here, we can select the backup option we require and click Choose Solution. Once this loads, we can read the general terms of use here, accept them, and click Enable Solution. To facilitate the network communications during migration, we want to ensure both source and destination data center are on the same vRack. When both data centers are on the same vRack, VLANs from the source data center will be reachable from the destination data center and vice versa. We can confirm this by going to Bare Metal Cloud, Network, and vRack. As we can see here, both data centers are on the same vRack. At this point, I will also change the name of the new data center so that it is easily recognizable during the migration. Here we can see the source vDC and the destination vDC. It is clear that there are more vSphere objects and components in the source virtual data center than in the destination virtual data center. Objects such as resource pools, network port groups, and folders will most likely need to be recreated in the destination vDC to ensure consistent migration. I have now recreated the resource pools, the network port groups, and the VM folder structures in the destination vDC in preparation for the migration. Note that other objects might need to be recreated, such as Datastore clusters or other folder types such as host and cluster folders and network folders. The goal here is really to ensure consistency between the source and destination vDC to secure a smooth migration for the virtual machines. As we can see, Datastore 991 is visible to both the source and destination virtual data center. So before we migrate the virtual machine's compute to the destination vDC, we can migrate the VM's disks to this global data store. This helps with planning maintenance windows since stored VMotion generally takes longer than VMotions and is harder to predict when it will complete. Doing stored VMotions now will mean that the VM's compute workloads will stay on the source vDC, but the VM's disks will be visible to both data centers. This means that during the VM migration maintenance window, only the compute will need to be migrated, which will be much quicker than migrating both compute and storage in one maintenance window. Note that we are only migrating VMs, not NSX components. If there are NSX edges that need to be migrated, we need to prepare the infrastructure beforehand to ensure a smooth move. The first thing we will do is add the new cluster to the source cluster's NSX Transport Zone. This will allow all VXLANs that exist on the original cluster to also exist on the destination cluster. This will help migrate the NSX Edge, as I will explain in the next section. To add a new cluster to the source transport zone, we go to Networking and Security, Installation and Upgrade, Logical Network Settings, and Transport Zone. Here, we will select the source cluster's transport zone and choose Connect Clusters. Now we will select cluster in the destination data center and click Save. As you can see, port groups are being created in the new data center VD switch. These are the VXLANs that existed in the source data center VD switch that are now being created in the new cluster. To migrate an NSX Edge gateway, we need to redeploy it as opposed to VMotion it. This will ensure the NSX manager's database is consistent. The main challenge here is that the NSX Edge gateway keeps track of the VLAN-backed port groups that is connected to via the port group ID. This means that when you try to redeploy it onto the new data center, you will take the port group ID that is connected to in the source data center and try to look for the same port group ID in the destination data center. This will most likely fail, so we need a way to have the NSX Edge gateway connected to a network that has the same ID in both the source and destination data centers. We will use temporary VXLAN networks created in the source transport zone to do this, since VXLAN network IDs will be the same across data centers, assuming both data centers are in the same transport zone, which is what we did in the previous step. So before we migrate, let's first ensure network connectivity is working. Here we can see that the web VM that is connected to the VLAN-backed port group can indeed contact the DB VM that's on a VXLAN-backed port group. To migrate the NSX Edge gateway, we will go to Networking and Security, NSX Edges, and choose the edge we want to migrate. In this demo, the edge is in high availability mode. So I will disable this service to minimize the downtime. We will now change all VLAN-backed interfaces, including the VM network, to temporary VXLAN networks. Again, these VXLAN networks were created ahead of time. This network is already a VXLAN network, so no need to change it. Once we've made these changes, we will see downtime for any VLAN-backed network. As you can see, the web VM can no longer communicate with the database VM. To redeploy, we will go to Configure and Appliance Settings. It is worth noting that this is the state that the Edge Gateway should be in after you disable HA. You should have just one appliance and one empty appliance. Click the cog next to the appliance and click Edit. And here we will place the NSX Edge on the destination data center and click Save. As you can see here, the Edge Gateway is now being redeployed. Once the Edge has been deployed onto the new data center, we can change the temporary VXLAN port groups back to the correct VLAN port groups in the destination data center. Remember, because both data centers are on the same vRack, VLANs will span across both data centers. Once we have changed the interfaces back, we can now re-enable HA. And finally, we can retest connectivity to ensure it is back. To migrate an NSX distributed logical router, we use the same theory as we did with the NSX Edge Gateway. However, this time there will be no need to change the interfaces to temporary VXLAN networks. This is because distributed logical routers in an OVH HPC will always be connected to VXLANs. So the process is as simple as disabling high availability if you wish, and then redeploying the DLR onto the new data center. Notice that because this is a logical router, the network disruption will be very short, if at all. As you can see, we lost no pings during the migration of the distributed logical router. So at this point, we now have the VMs on the source data center. The web VM is on the web VLAN backed by the Edge Gateway. The app VM is on the app VXLAN behind the distributed logical router. And the database VM is on the database VXLAN again behind the distributed logical router. The NSX Edge Gateway and the distributed logical router are now on the destination data center, and all communication continues as it was before. Again, the reason this is happening is because the VXLAN networks are stretched between the two data centers. So they continue to operate at layer 2 because they're in the same transport zone. And the VLAN backed port groups stretch the data centers because they are on the same vRack. Before VM migration, it is good to confirm that the source and destination vDistributed switches are on the same version. This is to ensure that vMotion between the vDistributed switches and the virtual data center will work as expected. In the case of the vRack distributed switch, you can self-serve the upgrade yourself. However, if the VXLAN vDistributed switch is not the same version between the source and destination, please contact OVH support to assist in the upgrade. Bear in mind, upgrading a vDistributed switch can impact VM traffic, so it is worth scheduling this task out of hours. Before we migrate any VM workloads to the new data center, we should be mindful of the NSX distributed firewall. This is because the distributed firewall can span all data centers and clusters and ESXi hosts that are prepared for NSX. And this span can cause some unforeseen situations during a migration. If we look at the firewall rules configured in this demo environment, we can see two rules in use. The first rule blocks traffic between the web VM and the DB VM and vice versa. And the second rule allows all other internal connectivity between the web, app, and DB VMs. Notice, however, that the first rule is not applied to the distributed firewall and is instead applied to the source vDC web VLAN port group. This means it will only apply to VMs that are connected to this port group. However, this port group only exists in the source data center. So when we start moving VMs to the new data center, this rule will stop working as expected. Let's take a look. Currently, the web VM cannot communicate with the DB VM, as we would expect. Let's now migrate the web VM to the new data center. Notice that the destination port group name is different in the destination data center. However, the VLANs are the same. The names are different in this demo to avoid confusion. The web VM is now present in the destination data center. Notice that now we can connect to the database, and this is not what we want. To resolve this, we need to change the distributed firewall rules in a way that will make sense before, during, and after a migration. In this instance, I will simply add the destination web port group to the applied to field. And publish. If we check the communication now, we can see that again, it has been prohibited, just like we expect. Bear in mind that this is just an example to highlight that care should be taken when migrating VMs when the NSX distributed firewall is in play. I will now migrate the remaining virtual machines. After VM migration is completed, we need to retest connectivity. Here we can see the web VM can ping the public internet. It can ping the app VM, but it cannot ping the database VM as expected. The app VM can ping the web VM, and it can ping the database VM, but it cannot ping the public internet. And the DB VM can ping the app VM, but cannot ping anything else. So with this, we've confirmed that after a migration, network connectivity is as expected. Before the migration, all 3 virtual machines were being backed up by Veeam. However, now, after the migration, we can see that the backups no longer exist. But because we have Veeam enabled on both the source and destination data centers, we can also migrate the Veeam backups by running the check backup jobs API call. This API call is a post call, and it requires the service name, so the HPC, and the data center ID. Note that this data center ID is the source data center, and the ID can be easily found in the OVH manager. With the check backup jobs API call run, we can now see that the Veeam backups are back on the virtual machines in the new data center. Once the virtual machine migration is completed, we will need to remove the old data center. To prepare for this, we first place the host into maintenance mode. Note, however, that in this demo, I have Veeam enabled on the old data center. And this means that there is a Veeam virtual machine that will stop me from putting all hosts into maintenance mode, as I cannot manually power off this VM since it is managed by OVH Cloud. So first, I will need to disable Veeam backup on the source data center by going to the OVH Cloud Manager portal, navigating to the old data center, and disabling backup. Once Veeam backup has been disabled, we can place the hosts into maintenance mode. Once all hosts are in maintenance mode, we can remove the data stores associated with the old data center using the OVH Cloud API. To do so, we will first get a list of all the data stores in use at the source data center by running the /filer API call. Remember, the data center ID is the old data center ID. Here we can see one data store in use. So we will use this data store ID, and we will remove it by running the filer remove API call. And you can follow this removal task with the task API call. And it is important to wait until the data store has gone from the vSphere client before moving on. Once data stores have been removed, we can now continue with removing the ESXi hosts. Note that in this demo, we can still see some data stores associated with the source data center. This is because these data stores are set to global and so are not tied to any one particular data center. To remove the hosts, we go back to the OVH Cloud API and run the /host API call to first get a list of all the hosts in the old data center. Again, this data center ID is that of the source or old data center. We can see 3 hosts in the data center, and we will need to remove each one and verify it is gone in the vSphere client before we can move on to the next one. We remove the host by running the /remove API call with the host ID. After all the ESXi hosts and data stores have been removed, the cluster can be deleted by right-clicking it and choosing Delete. The final step then is to remove the old data center. This can be done in the OVH Cloud API by running the Delete Data Center API call. Again, the data center ID is that of the old data center.